Now in topic 4 of chapter 1, we're going to look at rational expressions. And a synonym for rational expressions, sort of, is just a fraction. So this is a fraction, this is a fraction, this is a fraction. These are rational expressions. And when they use the word quotient, it just simply means they're going to be written in the form of a fraction. Two polynomials as a quotient. Okay. So we go on to simplifying rational expressions. And basically what we're doing here is to see if we have any factors in our particular expression that are the same. So we can cancel these factors out. And they're also qualifying that any factor in the denominator cannot be equal to a 0. Okay? Because that makes it undefined. So here the s's are common factors. S over s is 1. Anything divided by itself, except 0, is a 1. So we've simplified this. So that's basically what they want us to do here. Now I could write these out, but I see they've done it pretty well, and I will keep that in mind if I have to do it. So 12m over a negative 18. Well, the first thing you should look at is what will the sign of our end result be? And when you divide a positive by a negative, the result is negative. So we know there's going to be a negative in our final answer. And then we look at our 12 and our 18. What are the factors? Well, there's a common factor of 6 in each one. So 6 over 6 is 1. So in a sense, we use the canceling out principle. 6 will go into there twice, 6 will go into there 3 times, and we end up with this. And then the typical way of writing the negative sign is by the fraction or division bar. Now for letter B, gets a little more challenging because now they're saying, what can we factor? Well, this is a term, so you can't do anything with the 4. And this is a term. But notice if you just look at the numerator, you can factor an 8 out of the numerator. And you get this. Now that 8 is actually 4 times 2. Or you can factor a 4 out of there once. 4 out of there leaves you a 2. So this is what you get. And every number is over 1 that we don't write. So you can leave it like this. They want you to leave it in its factored form. But if you distributed and got this, that would be okay. Now in letter C, it gets a little more challenging because now we have a trinomial divided by a trinomial. And they want us to simplify. So we have to factor the top, factor the bottom, and you have to check your work. And then now these factors, k plus 3, factor out, and it leaves us with this. Now we're going on for a quick review of what we call multiplication and division. And pretty generally, for division, we have to look at something, but for multiplication, we just multiply the numerators, multiply our denominators, and see if we can cancel anything out. Nothing cancels out there. But notice what happens for division. And this is crucial. We have basically, this is multiplication, but now this is division. What we're going to do is take the division sign, convert the division sign to multiplication, and then our second item, we take the reciprocal of that. That is, we switch it around. The S goes to the numerator, the R goes to the denominator, and again, you see if you can cancel out anywhere, and that's division. So now let's look at some examples. Now notice in letter A, you can't cancel anywhere. So if you can't cancel here, it's just 2y over 15. But notice here now, there is a common factor of 3. So we can factor out the 3 there and get y plus 3 over, and I'm going to factor that 6, 3 times 2. And then this is going to be 2 times 9. And I could have factored that more, but I see that's probably all I can take out. And then here I can factor out the 5. Y plus 3. Okay. So now that I have it all in factored form, what can I cancel out? Well, these 3's will just cancel out nicely. This 2 will cancel out nicely. This y plus 3 will cancel out. So I'm left as an answer on the top with a 9 and on the bottom with a 5. And I believe that's what they'll have down there somewhere. Okay? Again, we're showing you the technique of doing it. Yep, that's what they have. And this one the same. You're going to carefully factor this, factor that, and cancel out wherever you can. Now, notice here it is in factored form, but here they have multiplied. Now they should accept this one as well as this one. If on a test, I would assume that if you had it like this and they counted it wrong, but that was on your blue sheet, your instructor would give you credit for that, because that's in its factored form, and they often say leave it in its factored form. But you're doing your practice, and if they show when you do your practice in Quizme's they want it in this form, then do it that way. Now here is a division that they're going to do. Notice we're going to change the sign of the division to multiplication and then take the reciprocal of this. Now in its reciprocal form, notice you can cancel out here. That's 1. This is 4. Can take out one of the x's. This is 1. So then your answer is going to be 8 times 4 is 32. And then on the bottom is only 11x. And that's the answer. So whatever method you use, you want to, again, take the reciprocal of this after you change the sign to multiplication, and then cross cancel wherever you can and write your answer. Now a good thing is to be sure to keep your original problem when you write it down, or you can write it in this form. Don't do what I've done here, where you sort of destroy the problem, and then you can go back to check your work. Now over here, notice they're factoring out a 9. And here you can do some canceling. And again, they're not showing you that, but I would. So let me show you that. So my 9 over here, I'm going 3 times 3. And my 18, I'm going 2 times 9. And my 12, I'm doing 2 times 4. Actually, I probably should do 2 times 2 times 2. There you go. So I put the 4 as that. Now we can cancel out common factors. One of these 2's with this up here. And this actually cancels out. So I get 3 times 9 is 27. And 2 times 5 is 10. And there you go. All right, let's go on. Now, to go over the rules for addition and subtraction, as we see here, if your denominators are the same, you just add your numerators. If your denominators are the same, you just subtract your numerators. So these are pretty straightforward. The 5k is your denominator, and you're going to add the 4 and the 11 and get 15. But notice you can cancel out a common factor of 5. So your final answer is 3 over k. Now, for something like this, it's a little more technical, but your denominators are the same, but you are subtracting now. So a suggestion for this would be change this to a positive, but make this term a negative now, and this a positive. You're going to be using that technique of, if this were in a parenthesis and there was a negative in front, you could remove the parenthesis and just change these signs. So now it's just a matter of adding them up. And let's do that. So we have a negative x squared and a positive 2x squared gives us just an x squared. 3 plus 7 gives me a 10. And there's a 1. And that's all going to be over your common denominator. Now I've seen students in Math Lab, they'll do the addition of the numerator, but then they forget about putting it over the common denominator, and of course Math Lab counts it wrong. Don't leave out the denominator. Okay, and that's what they're showing here in some detail. Now here, this is where it gets a little challenging, so I'll set this up for you. So we're looking for a technique to add fractions when the denominator is not the same. So what we have to determine by looking at these denominators, what is my least common denominator? Well, for the number part, I'm going to need a 6. And I just went 2 times 3 to find it. And for the p part, I'm going to need the highest exponent, which will be p to the second power. So that's my denominator. Now, the technique I'm going to use here is to multiply anything by a 1. Notice from our first topic, we said we could multiply anything by 1 and not change its value. But this 1 can have many forms. For instance, the 1 can be 4 over 4. That's a 1. And when I do that, I get 4/8. Now remember, I'm multiplying 1/2 by a 1 in the form of 4 over 4. But if I wanted to simplify this, I put my factors of 4, 1 times 4, 2 times 4, and I would cancel that out. But now what I want is to get each term to have this common denominator. So what do I have to multiply this first term by? It's going to be a 1 in the form of what? And if you said 6 over 6, that is correct. You've multiplied this first term by a 1 in the form of 6 over 6. So our denominator now becomes this, and our numerator becomes a 42. Now what do I have to multiply this one by to make it this common denominator? And if you said the 1 is in the form of 3p over 3p, you are correct, because 3p times 2p is 6p squared, and my numerator now becomes 27p. And what do I have to multiply this by? What form of 1 makes this denominator 6p squared? And if you said 2 over 2, that is correct. Now notice we have like terms now. We have a 42 and a 2. So my final answer then will be 27p plus 44 all over 6p squared. And that's what they're showing you. And you got a little animation of what is in your textbook. Now remember, if you have any questions on these, you bring them into Math Lab. Now this one, I'll use the work that they have there. Save a little time. But what would your lowest common denominator be? Well, you'd have to take this one, and what's the factoring of this? Well, this is the difference of perfect squares. So we have this and we have this. And this, what I factor, we have this and we have this. So what will be my lowest common denominator? Well, I need these two, k plus 1, k minus 1. And the rule is, what's the greatest number of times that any factor appears in any denominator, or a factorization? And here, this appears once there, so I need it once. Here it's once, none there, but I need it once. And here this appears, so I need that once. Now I have this then, and remember I'm going to make this a negative, a positive, and I'm going to put a negative sign right there as a little technique, and put that in parentheses. So I have this as my common denominator of all of this. So what does this term in the numerator need? It has this already to become this. And the answer is, and I'll change colors, I have to multiply that k, I'll put it up here, times this one here. K get carried away with the x's there. K plus 2. Alright, that'll give me this. Now this one here, keep in mind there's a negative there now, is 2k squared minus k minus 3. Which one is this missing to make it this? Well, it has a plus and a plus. It needs this negative over here. So this one needs to be multiplied by k minus 1. Okay, well again, this one is a little challenging and tedious because now I have to multiply this by that. And I don't know if I mentioned this to you, but I would do this vertically. So this times this is positive 3. This is going to be a positive k. This will be a negative 2k squared. Now this will be a negative 3k. This will be a negative 1k squared. We don't usually write the 1. This times this is going to be a 2k cubed. So now I get 2k cubed minus 3k squared minus 2k plus 3. And again, keep in mind this is all in parentheses. And what's out in front there? A negative sign. Wow. So now what I have to do is take away the parentheses and change all these signs. This will become a negative. This will become a positive, and this is going to become a negative. And then I'm going to distribute that, and I get k to the third plus 2k squared, and then integrate that into this, and then finally that will be my answer all over my common denominator. And just this one problem will take 5 minutes or more. Let's look at it in the book. Okay, look at that. Wow. So this is what you end up with. Okay? All right, we're going to take a quick look at what we call complex fractions. And there's a couple of ways to do this, but we'll do it the way they show us here. And that is to put like a big parenthesis around the numerator and around the denominator. Now we look at the numerator and denominator and say, what is my least common denominator? Well, here it's k, and here it's k. So we multiply these by our least common denominator, which is k. Now, this is multiplication. It looks like an exponent, but that's not an exponent. So we then go 6 times k is 6k. Now here, the k's will cancel out, and we get a negative 5. Then we go 1 times k is k. Here the k's cancel out and we get plus 5. And that is our answer. Now there are some others that are more challenging, but they're done pretty much the same way. And if you have any questions on something that you don't see here, ask your tutors and instructor. They will help you on it. All right.